Hello everyone, welcome back to Dragonfly Engineering. So this week we are going to start the exploration of Mastercam, which is the new toolpath program that I purchased along with this new CAD/CAM computer as well, which we built in a previous episode. So I've been going to some classes and teaching myself Mastercam, so I'm definitely still a beginner, but I think it's useful to show you guys a beginner's viewpoint of Mastercam. And in fact, I'm going to a 3D machining class for Mastercam tomorrow. So I'm definitely learning still, but I've picked up the basics on how to program a part in Mastercam that is then machined on the 5-axis Haas UMC 750. And I was able to determine how to rotate the part around to machine. The goal is to machine a complete part with a single setup. So we're going to see if we can do that with the part that I need to machine now. And it's similar to a part that we machined before on the work holding system 6 million, which I showed you guys about 5 episodes ago. So after I finish toolpathing or creating the program, the G code to machine our part here in Mastercam, then I'll take you back out to the Haas 5-axis UMC 750 and we will load the stock into the fixture that I made in a previous episode, and we will machine a part, hopefully all of the sides in one operation, but I think we may have to have a slight secondary operation to clean up one tool radius. So let's dive right in. I'll meet you over here at the screen. I think I'll do the old gamer style head in the corner of the screen and then record the whole screen as we work. Okay, our screen's recording and the video is recording on the camera, so we will start off by starting Mastercam, and it checks licenses and stuff. I might have to blur that part out. All right, so here we are, and it's still starting up. This is Mastercam 2024, and I am going to start the project by opening up a existing fixture. Here we go, 5-axis fixture with base. So I'll double click that. Now what we've done here is bring in a pre-existing fixture that's been generated in previous operations with Mastercam or previous milling operations. And you can see this is the rotary table for the UMC 750. And then this green block is a spacer block that I added recently. And then this purple block is a additional riser block which bolts down to the mill table. And I use all of these set screws up here. These are 1/4 20-inch set screw through holes, or threaded holes, 2 rows on each side, that will mount the stock in to be machined. And then additionally, this gray block up here is another riser for kind of skinny tall parts, because sometimes the tool holder or other things will actually get in the way of a complete tool depth to come in and machine the sides of skinny parts because they're just too skinny for this. I think this is a 4-inch wide or approximately 100 millimeter wide fixture. So for this part that we're going to machine, which I'll bring in a second, we don't need this upper fixture. So I'm going to click on this fixture and I'm going to delete it by hitting delete. And then there's some additional remnant things like a plane, a centerline plane that were drawn in with sketches or wireframes. So if we look down here in the bottom left of the interface, there are levels. So we can click on levels and we can turn things on and off here. So we can also turn on and off visibility of planes. So for instance, I'm gonna turn off the visibility of the UMC mill table. So I'll click this X and now you can't see the mill table. And I'm going to click through and see if I can find the holes that I don't want to show visible. And this level here has the holes that I didn't want. And then we can figure out where this other thing, okay, that's our fixture. And okay, fixture extension. So we'll hide that one as well. One second, someone's texting me. All right, I'm back. So now we can turn back on. Actually, we can just leave the mill table off. But if you want to click it back on or off, you can just click here and see it, because sometimes it's good to make sure that the tool isn't going to crash into your table and stuff. But we'll turn off the visibility there. And now we've just got our riser block and our fixture. So now what we're going to do is merge in the part that we're going to machine into this Mastercam workspace. And we will click on Mill and pick the Haas UMC 750 5-axis mill. There's also a 3-axis mill, this other mill here. But in our case, we're going to do the 5-axis mill. So I click that to choose the kind of the work environment to be a 5-axis machining environment. I am going to go to File, and then we can click on Merge. And now it's asking us what do we want to merge into our existing 3D model here, which is effectively our mill fixture. So I'm going to tell it to look at SolidWorks parts, and we've got this corner column beta, which is the part that we're going to machine in our work environment that we're setting up here. So I'm going to click on corner column beta and open. And now it's asking us, do you want to align it? But I think we'll just select a position for now. So we'll click just in the workspace here, and you can see our part that we're going to machine is here. But it kind of just stuck it in a random location within the workspace. So now what we want to do is we'll align this part to our fixture outside of these predetermined things, because I haven't used that yet. So we'll just click the checkbox. So we will go up to transform, because we're going to transform the location of this part, in dynamic. So we'll click on dynamic, and now it's wanting to know what you want to move around. So we're going to click on this solid model right here, which is the part we're going to machine. And I'll click on end selection that says we're done selecting what we want to move. And a lot of times this little center target, this center of mass datum shows up when you do selections. And then this thing over here, I forgot what it's called, like a gnome or something. Anyway, this thing that's being dragged along with our mouse pointer, you can attach this gnome to the center of your part or any feature of your part. So we'll just click it on the center right now. And now we can use these XYZ arrows and these rotations arcs to rotate our part around and get it to the orientation that we want. So I think we'll rotate it horizontal first. So I've grabbed rotation, and now I can spin the part to 90 degrees, or I can type in -90. And there we go. And then I'll hit enter to accept that. And then we can also just drag the part by grabbing like the little ball in the middle to do a dynamic drag, but you're never quite sure where you're at in the workspace. See, we're still kind of far away there. Or you can grab individual axes like this y-axis and drag the part over closer to where you're working. And now we can drag the part up, clicking on the x-axis and then clicking that we're happy there. And I think what I want to do is rotate this part 180 degrees. So I'll click on this rotation segment, and then we can drag with the mouse and roll it 180 degrees around. Or I can actually enter the number that gets us where we want to be, which is this. Whoop, of course, when I let go of the mouse, it drifts a little bit. All right, so I'm going to type in 180 and enter, and then it locks it to exactly 180. I hit enter again to accept that value. And then I'll keep dragging this part until it's basically going to exist in the space above our clamp, which will exist inside of the machining stock that we're going to use. So there's about right. Then we'll drag it up. And so our stock is going to actually exist around this part and be clamped into the base. So we're going to have a 1-inch or 25 or 12.7 millimeter tab that's going to fit into this slot, and our stock is going to encompass this pink part. So I'm going to keep bringing it around. You can also drag on a corner and then snap it into another corner, but we'll keep it simple for now. And we'll just bring it into where we want it to be. Basically centered there. It doesn't have to be exact because we're just going to machine into stock all the way around the part. And the actual final part will just exist in the mill wherever we stop dragging it to. And then escape to not select again. Oh, but yeah, I guess we still need to do one more time. Another thing we can do to lock in the angles is down here in this cube, you can click on the front and it'll bring your workspace to the front axis. Click on stock setup and I'll say let's create a rectangular stock, and we'll click on our part here and click end selection. And here you can see how it's supposed to show like a shaded representation. Let's see if it does it. Well, it's not doing that at the moment, but it shows the size of our stock that we want. So we want the stock to be bigger than the part itself. And if you look over here, there's like a little dot in the middle of the stock here, the anchor point. So, and then it gives us the sizes of the stock in inches. So 6 inches by 0.626 inches thick by 1.3 inches tall. We can increase the size of the stock. So instead of 6.06 inches, let's make it, actually we can just add to the end, plus 0.2 inches. So that'll be 0.1 inch per side. And then we can do the same with width. So we're just going to add 0.1 inches per side. So plus 0.2 for a total. And you'll see that the stock increased in dimension about the center of the stock because we chose this center point. If we chose this corner, then the stock would grow only in one direction and anchor at the corner that we choose. But since we chose the center, it's growing about the center, the stock representation. It's supposed to show like a shaded block around here, but it isn't doing that to kind of preview the stock. So I guess we'll figure out why that is the case, but we'll add plus 0.2 inches to this dimension as well. Okay. And it seems to be not wrapping the stock around the part correctly. So what we can do now is lower our stock down. So we'll say right now the center of the stock is approximately 8.5 inches up from the mill 0 point, which is at the gimbal rotation point. We can talk about that in a little bit. So I'm going to take 1/2 inch off of this, and we'll just tell it to be 8 inches. So there you can see I guess just the dimension lines for our stock shows where it is, but normally it shows like a preview, so I'm not sure why it's not doing that. Anyway, I'll hit check. And here it's showing a wireframe box around our stock. And our part is completely within our stock. Now if we go up here to stock shading, it should show the stock shaded. So yeah, here's either wireframe or shaded. So I'm going to leave the representation of our stock shown as a dotted wireframe. And the actual stock that we're going to make is going to it's going to be bigger and it's going to drop all the way down into this key. All right, so now we can start with doing some machining operations. Okay, so the next thing we want to do is set up our tools. Now the Haas mill has 40 tools loaded in it that are pre-measured to the 0 location, which is down here at the base of rotation of the trunnion itself. So this trunnion rotates all around this point in the mill itself. Now the Haas mill does have work coordinate system offsets, which is a way that you don't necessarily need to program your part offset from the true rotation point of the gimbal stage of the 5-axis mill itself. But I like to have the part reference the physical 0 rotation of the gimbal just to help reduce the error that can occur from the calibration of the mill with a ball probe to map all possible orientations. I don't want to get too in the weeds with this, but But you don't necessarily, if your mill is set up to be able to do rotational offsets, you don't need to have your Mastercam 0 location set up at the gimbal point of the mill, but it does help if you need really accurate rotations, because there's less air if you have to calculate the location of my hand way out here relative to the 0 point when the mill is rotating around. If the code knows is programmed at the orientation point, then Mastercam is figuring all of this crazy like extended rotation out instead of the Haas mill. But in this case, Mastercam is helping with figuring out the rotations out at an extended length from the point of rotation of the mill, and the Haas mill is also calibrated. So we have like 2 calibrations that are helping to tighten up the tolerance on our part. Hopefully that made sense. All right, so back to tool setup. So we're going to go to tool setup, and right now we don't have any tools loaded. So oh yeah, here we go. So we click on this button to open a tool manager so that we can open up a tool library. And we will say that we will open up this tool library from Dragonfly, which is the mapping of the 40 tools on the Haas UMC that that I mentioned that we've already preset the heights to. So we'll open that. And now what we want to do is start pulling tools from our tool library into our working model here. So I'm going to grab like this 3/8 inch end mill and hit this button and bring it up into our active tool list. And we're going to use a 1/4 inch end mill, so I'll bring that guy up as well. We're also going to use a spot drill to set the location of our drilled holes, which is basically almost like an engraving tool. In fact, tool number 10 is a 1/4 inch chamfer mill for deburring edges. And we've got a bunch of other tools, and we can grab more of these as we get to the point of doing different milling operations. For instance, I know that we need this drill, a pilot hole for an M3 by 0.5 roll tap, so I'll bring that up because we've got tapped holes. And then we'll need the M3 by 0.5 roll tap as well, which is right here. M3 by 0.5 roll tap, right hand. So I'll bring that up into our active workspace. Okay, that should get us started. Okay, so for 5-axis machining, there are planes that you have to define. So over here in the plane manager, we've got the top plane where the work coordinate system is set, and then construction plane and tool plane are also set. So the work coordinate system is kind of the global coordinate system of Mastercam, and it's also the default coordinate system of the mill itself. So end mills, in the spindle pointing down, and the table's here, and this is the top work coordinate system, which for the first milling operation will also be the construction plane and the tool plane. Now with 5-axis, if you want to machine something on the side, and if we look down here on the little cube on the left side, then what we would do is keep the world, is that world or work? I think it's either world or work coordinate system. Maybe world coordinate system. We want to keep that one referenced to the mill and Mastercam, but now we want to switch to the left plane of this part so that we can start machining from this direction to like machine this surface. So I'll explain that in a second, but let's do our first machining operation. Before that, it is easy sometimes to create extra lines that you can select. So what we want to do is, just in aid of machining, is I'm going to create something called a bounding box, which basically just draws a box around your part. And it's selectable wireframe lines, like sketches, that you can use to do machining operations. So we're going to do a bounding box. In fact, I'm going to make a new level called level 1006. We'll hit bounding box, and I'll select the part in selection. Okay, and then we got our bounding box around our part itself. So, okay, that's good. Again, I'm still learning this. Okay, so here's our green outline of our bounding box. All right, another thing I'd like to do is extract all the curves of our part. So I'm going to go to wireframe and then curve all edges. So we'll click this button and then we'll select our, if you triple select, you can select the entire 3D model, and I'll hit End Select. So you click the mouse 3 times and we will accept that. Okay, so time to do our first toolpath. And I am going to go to, let's see, toolpaths. And what we want to do first is to face off the top of this part. So if we look at our plane or our levels, we are on our work coordinate system is set to top, as well as our construction plane and our tool plane. So we're basically going to machine this like we're sitting on a 3-axis mill. No fancy rotations or anything for the top face. So I'm going to click on face, and then you can select either wireframe here or 3D surfaces, and you can select the selection method or filter for how you want to select surfaces to 3D machine. So if we clicked, right now whole face or whole loop is selected, so I can click on this face, or I can click on the loop. Or if we wanted to click the wireframe or the bounding box that we made and fuddled about to get it in the right place, we can click on partial or full chains on wireframe. So let's click on, let's do partial frames, and I'll click on our first edge of the wireframe bounding box that we made, and I'll click this edge, and we're walking around clicking the profile that we want to machine. So you can also, this red line is a preview of where it thinks it wants you to go next. So we can either keep clicking around like so, or we can also click on this advance. Oh, I guess we can't, maybe because it's already figured it. Anyway, so let's just keep clicking around until we selected a closed profile, and then we'll hit check. And so we've selected one chain geometry, and now we are going to go through the sequence of basically giving all the instructions to Mastercam to plane off the top of this part. So you can tell it to tool holder, depth of cut. We can, since we basically, let's see, did we pick the top surface? Yeah, we did. So actually our depth of cut will be 0. Actually, no, we can do a rough and then a finish. And finished cut will have one finish, whoops, and we'll leave 5/1000ths on this surface to cut down to. And again, it's the stock that we defined. I think in this case, Mastercam uses that stock to figure out a rough pass and then a finish pass. So we're saying cut up to 50/1000ths, which is approximately 1.3 millimeters. And then for the final pass, we want 5/1000ths, or like whatever that is in millimeters, 0.1 millimeters for a finish. We can also preview. So if we click on the blue cross here, you'll see the toolpath that it generated based on our initial instructions. And you can see some things going on. For instance, like our blue toolpath didn't actually get down to the surface. So somewhere in here, we have an additional step. So if we keep looking around, like cutting parameters, you can see here we got stock to leave on floor is 50/1000ths, or 0.05 inches. So we'll make that 0. And now we can preview our cut again by hitting this blue cross. And now you can see our cut is getting down to geometry that we want. And we're machining the top of the part relative to the mill, because our coordinate system, our tool system, and our work coordinate system are all on the same plane. So the yellow lines show the rapid, and then the blue lines show the cut. But we have too much stuff going on here, so I'm going to go back to depth of cut, and maybe we'll, let's see, we can turn off, or actually we can just make the rough step bigger. So let's make it 0.15, because this is a 0.375 inch end mill, so 0.15 isn't that much. So we hit the blue cross again, and now you see that we have two finish passes, even though we said only one finish pass. So if we make this 0 and hit the blue cross again, then you can see that we basically, our finish pass has a little bit of meat to it. So we do want the finish pass, but let's make our rough pass 0.2. Oops, I keep adding an extra 2, or a point. And we'll hit the blue cross again to preview. All right, and now you can see that our full travel of cut through all the stock and that we defined earlier, and then we've got our finish pass, which is just 5/1000ths of an inch, or approximately 0.12 millimeters. And I think we can show the stock. I may have to finish this operation before we can show the stock. And then linking parameters basically defines the depth of cut. So if it looks good, then you're okay. And then there's incremental and absolute, which may be a little complicated to talk about here, but so we'll skip that for now. But you can pick top of stock and depth of cut if you don't like what the program has deemed it thinks that you want. Okay, so we're going to hit check, and I think I need to change the battery on my camera. Okay, so we've machined the top of our part. At least we rough machined it. So now if we want to do other operations, like for instance, we want to cut this notch in, then we can pick on this edge here. Well, actually, no, we gotta tell it to do a toolpath first. So let's go to toolpaths, and we can pick on contour, and we will select this edge using the wireframe. Actually, let's do it with the 3D select this time. So we'll click on 3D select, and then here you can select edges, because right now the active selection is a full face or the outer edge of a full face or a loop. So we'll click those off, and you actually have to, you got to select something first before that unblues or unselects. So now we're going to do a 3D select. So we'll click on 3D and edge. I'm going to come over here and click on this edge right there. And we only want that single edge for contouring. So I'll say OK. And then we'll select our contour operation. I'll pick the tool. It'll be still the 3/8 inch flat end mill. Whoops. Oh, and it did it. I got a little ahead of myself. So we'll go over to toolpaths, and we'll go back in. So we made two toolpaths so far. This is the toolpath, I guess, navigation tree. So our first one was facing, which is this one, and you can see it highlights it there. Our second one is the contour 2D, but it's cutting the wrong side of our edge. We want to cut away this metal. So I got a little overzealous and clicked OK, but we'll go back into the dialog for the contour cut. And a few things we want to do. For one is we don't want to just skim the top, but we actually want to cut down to the depth. But to do that, we actually set the depth and linking parameters. But prior to that, we still want to do a rough and a finish cut. So depth of cut settings, basically. So right now we're going to cut for a rough cut or a rough pass 0.1 inches. And for a finish pass, we will leave 10/1000ths or cut off 10/1000ths. A single pass of 10/1000ths for a finish cut. Okay, so compensation direction. We want to go to the right side. And then again, we can hit the blue button. And then you can see over here, it'll give you a real-time preview of your changes so that you can say, yes, I'm machining on the right side now. But our depth is still not correct. So what we will do is go down to something called linking parameters. And then here is where we can actually, like I was saying earlier, tell the mill where the top of the stock is and where to cut to. So our previous operations, we faced off all the metal on this part. So this is our new kind of top of stock, this surface right here, for our machining operation to cut this notch out. So I'm going to select over here, top of stock, and I'm going to pick on this edge here and say this is where you should know that there's the beginnings of metal to cut off. And since our origin is like way down at the origin of the mill, it's saying it's almost 7 inches, which is okay. So now what we're going to do is define the depth of cut, and that's going to be this edge. And oh, look at that. The two numbers are the same, but we'll hit the plus and see what happens. And our cut probably went off in outer space somewhere. Okay, so actually we'll hit the check because it no longer gives the option to select. So we'll go back into parameters and we will go back to linking parameters and we'll try that again. Top of stock is here, 6.9, and then the depth is here. It should be two different numbers, but it isn't. So let's start playing with absolute numbers. And I will try this again. Top of stock is here. Oh, okay, 1.5 inches. And then the depth is here. Why is it saying the same number over and over again? All right, it's being fussy, so we'll try the depth again. Oh, well there it seems to maybe work. Let's see what that looks like. Okay. So our top of stock we set to be absolute, and then our depth we had to set it incremental. But I think there's a refresh bug or something. This is the first kind of release of the 2024 version of Mastercam. But I actually had to exit out and then re-enter to get this plus preview to work again. So yeah, we're still working through some bugs apparently with Mastercam. So right now we're going to cut this slot here, but we're not actually cutting all of the metal off to the end of the part. But what we can do is go back to cut parameters, and under multi-pass we can tell it we want to do, let's say, 3 passes at 1/4 of an inch per pass for the rough cut. And we'll keep the side finish cut still at 0.01. In fact, we can do a spring pass. And a spring pass basically means just go over a finish twice to machine out the flex in the end mill when you were machining the first pass. So we hit the plus button here, and now we've got 3 cuts to cut out this material. All right, so I like that, and I've got it set up to automatically save. So we've got our first 2 machining operations here, facing and contouring the notch. Now we can also play these. It's called back plotting. So we'll hit the play button, and it's going to show our contour because that's the one I had active, and it'll show a preview of the path and then the cut itself, and then it goes back for the finish pass. It's going a little slow. I think we can speed this up. Or we can also click on the entire toolpath group and then backplot that. Oh, I guess I have to exit this first. So we'll select everything in the toolpath group, which is 2 machining operations, and hit backplot, and it will show us how the toolpath works for both operations. So here we're facing off. And now we are cutting the notch. Okay, now we're going to get into the interesting 5-axis aspect of machining with this 5-axis mill and this Mastercam 5-axis setup. And what we're going to do now is change our planes to machine the end of this part. So this guy right here, this shape we're gonna, or this face we're gonna face off, we can drill this hole and profile this part. So we will, to do that, we need to basically change the tool coordinate direction and the construction coordinate direction, but leave the world or the work coordinate system the same on the mill, because the mill is still just sitting there on the floor. It's not, the whole mill isn't going to rotate sideways to machine the side of your part, mostly because the part is fixtured to the mill. But what you want to do is tell Mastercam and the mill, keep the mill from rotating, but rotate the part inside of the mill. And to do that, the world or work coordinate system doesn't change, because that defines the mill sitting on your floor. But you want to change the construction tool, the construction and the tool plane geometry to rotate at 90 degrees as the mill is still sitting like this. So now, instead of the end mill cutting down like this, it's going to come in this way and machine the side of your part until you change your tool and construction geometry to some other orientation or back to top. So world coordinate system will remain top. So we'll go to planes here, and that's the WCS. And I may be calling it work or world, but I'm used to the KUKA robots and they call it world coordinate system. And then the construction plane and tool plane are these. So I am going to now go to the right by looking at this cube down here, the right side of our part. That we're going to update the construction and tool plane to be on the right, not the front, but right. Okay. So now when we start doing machining operations on this face, the end mill is going to come in from the side and do that machining operation. So we can do that now. So we will go back to toolpath. Oh, and you can also look down here and see what your coordinate systems are set for. Cut plane and tool plane and work coordinate system. So they call it a work coordinate system instead of world coordinate system. Okay, so we will go to toolpath, and what we want to do is face the end of our part here. So I am going to go to face, and again it's asking us to select our profile. So we'll do the 3D select with a full face, and we'll just click. No, actually we can't, because there's a circle in there and it may get confused about that. So we will clear our selection and we'll tell it to select the outer loop of this face. And you have to let it find the right one. Okay, here is the profile that we're going to face. So we'll select OK. And then we're going to do the same thing. We're going to find our tool, 3/8 end mill, and it keeps kind of the settings from your previous operations. Stock to leave on floor is 0. Depth of cut, we're going to take up to 0.2 inches rough cutting, and 5 thousandths as a finished cut. Linking parameters, we'll see what happens there. So let's click the plus button to see a preview of where we're at. All right, so it's saying, oh, you're machining from all the way out here into your part. And to be perfectly honest, I think if we hide all of this stuff, then it won't actually account for this. But let's play with the linking parameters again. So, and linking parameters, let's see where we're at as far as our cut. Okay, so it's still wanting to cut from all the way out where I guess the stock was, or the fixturing was. So I am going to change that to 0. And then we'll see what happens. All right, so now we are basically just facing the side of our part, but you can see that we're coming in from this direction. So I think we'll say top of stock is 0.1 and our depth is 0. And then we'll update that. And now you can see that by giving ourselves a little extra definition of top of stock, we're now able to cut our rough and then do our 5/1000 finish to the face of the part. So Mastercam is just interested in the surface that you clicked as the finish, and then you can define top of stock to be bigger coming off of that. So, but we are using incremental. If we used absolute, let's see what happens then. Oh, then it goes back to basically no stock. So again, I'm still figuring out this aspect. So if we incremental versus absolute, but we'll hit plus again, and now our finish cut came back. So bear with me, but I'm still learning. So anyway, I think we are good with this cut. And now what we want to do is let's drill this hole. So we will do a drill operation, and our work coordinate system is still top, but our cutter plane and our construction plane is still on right. So our end mill is going to be coming in from the side, or our drill in this case. So let's pick on this hole, which is going to be a 4mm hole. And I'm happy with that hole selection. There was that red cross there. And we'll pick a tool, and I don't see the tool we want, so I'm going to open our main tool library from the Haas mill. And it knows that we're drilling holes, so it's kind of filtered out everything except for holes, or tools that will make a hole. So tool number 11 is a .166 drill. So we will choose that, and you'll see how it moved tool number 11 to our active tool list over here and selected it. Or let's just check it to make sure it's selected. And then cut parameters, we are going to drill peck. So we're going to peck a hole because it's going to be a deeper hole. And then say linking parameters. This is basically where you set all of your planes for clearance planes and approach planes and cut planes for drilling and machining. But in Mastercam they show you these nice planes in the drilling operation, so you can really understand where your drill retracts to. This is the retract plane, depth and stock plane. So depth, we're going to define it manually. We're going to say we're going to cut down minus 0.375, which is about 9.5mm. And I'll hit enter. And now you see the depth plane went down deep into the part by the amount I defined. And then the top of stock is at our surface because we did a facing operation before. But if we wanted to give ourselves a little clearance, then we can say 0.1. And again, incremental versus absolute is a little tricky. And then you see here our top of stock plane moved off, and our retract plane, which is defined by the top of stock plane, also moved out further. So this is our drilling operation. Up here under tool, you can set the feeds and speeds. So right now the spindle speed, we'll say 2,000 RPM, and feed rate we'll say is, let's make it 7 just to be safe. And then we'll hit check. All right, so now we've got a drilling operation. So I'm going to go back to the toolpath tab in the bottom left to see our operation. So we can see our drilling operation is this little blue line, and our facing operation is this line, or this milling path on the side. And then when we switch back in time to the top machining, you can see our work coordinate system, and our our tool plane is top. So now this operation is going to be pointing down from the top. And so is our contour from that direction. So let's preview all of this. So we'll go back to toolpath group 1, which selected all of these milling operations, and we're going to hit backplot. And we like those settings, so we're going to hit play. And here's the tool cutter, or the tool holder and mill machining the top of our part, profiling it, and then we're cutting the side and drilling the side. So the point in time where, oh, we've got a problem of some sort. That's red. Oh, maybe this, oh, okay, red indicates the, I don't know what that means. Must be some problem with the, let's see what it, not sure why it's red there. But this transition point, defined by this little line, which maybe you can see on the screen, is where the mill will go to a safe location. The tool pulls all the way out, and then the trunnion table will rotate the part 90 degrees, even though physically the end mill is still vertical in the physical mill. What really happens is the part rotates 90 degrees like this in the mill itself. So here's our trunnion point, 0 point of rotation, and the part will rotate. And the tool is still physically vertical in the world, and it'll machine our part in this side orientation, and also drill in the side orientation like that. So I think I'll do the rest of these tool paths, and then I'll be back and show you the full set of tool paths, and then we can take this out to the mill and machine the part. All right, so we're back, and I've finished out I believe most of the toolpath operations. So I'll hit Alt-T on the keyboard, maybe. And we can see our toolpath here. I think I'll get rid of the colors, clear colors, there we go. And yeah, these are the various toolpaths to machine this part. You can see we're drilling from the back, but I think I just have a spot drill coming from the back at the moment, so I may have to add a couple more drill bits. But we can do a simulation on this milling operation to see exactly what we're dealing with, and see if there's any issues with gouging the tool through the part, or excessive speed, like a rapid from one tool operation to the other, kind of plowing through metal. Excuse me. And all the other issues that may or may not pop up. So yeah, so to do that, well, I guess the first thing we can do is do a back plot, which is basically the animation scheme in Mastercam itself. So if we go to Tool Paths in the left pan over here, or the left tree, and we click on this icon right here called Backplot, it will animate the entire operation. So we'll hit play, and it will go through the various operations where we flip to the back, do some machining. We can also zoom in if we want. So here we're profiling that shape, and then we're drilling holes and drilling all holes all the way around, machining this pocket or this slot. And now at the bottom we're cutting out the part from the stock that's clamped into our base. And there's probably going to be some problems at the bottom because these yellow lines usually depict a rapid travel. So we may actually break the tool off because we're plowing through just solid metal here at the bottom. But to confirm that, what we can do is click on this little icon, which is a kind of a mass simulation program that is associated with Mastercam. I think it's called Simco, but I don't quite recall. But if we click this button, then we get a different, let's see, what is this called? Well, I guess this is, let's see, what is this? I'm not sure what this interface is called. But anyway, this will do a mass removal simulation of our machining operation as well. So you can see it imported our fixture, our mill table, and our stock without the extra stock down here that's going to tab in, because I don't want to go through that. And now all we really need to do is hit play, and it will show how we cut away material in our part and show any issues that may arise. For instance, this red here shows a gouge, which is probably due to a rapid travel. And we see other red indications here, which would indicate like a tool gouge as well. And we can check out the machined part versus our model. So you can see this is going to be a tap tool, so there's a little extra material left there. And it could be that I need to face off this tab. I need to look at the model itself. But I think I need to cut some more material off there. And I definitely need to fix this high-speed rapid through the base metal, because you can see it's highlighting. This red is indicating, oh, you're probably going to have an issue there, as well as like a lead out travel here, which may have been too fast, or a gouge in. And then looking around at the back of the part, you can see that I'm leaving a little flap of metal here. This is a typical like remnant in 5-axis machining. So that we basically machine away the entire bottom of the part except for this strip of sheet metal here. And we can back up through the simulation. Okay, so there I'm machining away the last bit of material to the left. Yeah, so I think that'll be sufficient, because we're going to have full support here and this whole kind of sheet metal tab here that will just tear the part off the final geometry. And then we'll have to deburr this edge. So I may make this tab like a little thinner than it is, like 20/1000ths of an inch, or about 0.5 millimeter. And but we will have a tool radius here, and I gotta back out the rapid travels for this contour operation, so that we don't plow and potentially break off the tool in high-speed travel. So we'll close out of this simulator, and then we'll go back to the contour, which is this one, and we'll go to parameters, and then linking parameters, and then retract. I'm going to say absolute instead of incremental. With incremental, it'll back out a little bit each time, but absolute, it'll pull it all the way out every time. So we'll apply that, and now you can see that all of our retract heights come to the same height, but we're still kind of down inside of the stock. Remember, the red indicates, this red outline indicates the stock, which we can, yeah. Anyway, so what I'm going to do with retract plane is we're going to make that 0.4. And then we'll hit the blue cross to apply that change. And now our retract is outside of the stock, but just so that I don't have to be super careful with the cutting of the rough stock, we'll make a 0.6. Retracting out of the cut before it travels back to the beginning of the next pass of the contour. Okay, so that should have fixed that issue.